Hey students, I'm going to go through some of the construction pieces that we just saw in chapter 12. So I'm going to get my tool out, got my compass. I'm going to use this as my straight edge. And so let's talk about some of the pieces they had you try out in chapter 12. One of them was being able to take a length, something like this, like AB, and transfer it anywhere you want. That means take that length anywhere you want. So think about a line. We'll call this line L. And line L has infinitely many points. So you can choose any point you want. I'm going to pick a point that's right here. So I'm going to call that C. Now grab your compass. If you want to capture this length, remember the length is measured between the two pieces. So extend it out, put the pokey part on one piece right here, and then adjust the length using the wheel. That's my recommendation. Use the wheel. And then do a little bit of a turn to make sure. Okay, perfect. This now measures the distance between these 2 points, measures that length, AB. So take that, put the pokey at C, and then again, not straight up and down, tipped, and then make a gentle turn, keeping pressure on the main side. That length that I just created, this length is the same length as AB. And I would say this is true by construction. So here's how I'd write it. I'd write AB is congruent to CD by construction. Okay. Well, let's see how we can do something else. Let's see. They might give you an angle, and they want this angle to be transferred somewhere else. Like maybe I want the angle coming off here. So what's interesting is as we do an angle, we're actually we're going to need some points. So I'm going to call this B. I'll make a point on the side A, and I'll make another point down here, which I will call C. So I'm starting with angle ABC. And I want to move that angle so that down here I recreate the exact same size exactly. Okay. So I'm going to come down here and I'm going to use some different points. So this will be D and this will be E. That's fine. Okay. And now what I'm going to do is this. I want you to kind of watch what I do. Well, probably the easiest way to do that is to come up here, and I could lock in any one of these lengths at all. I'm going to choose to lock in BC. So I need to shorten this down a little bit. Right to there. Okay. So I'm going to lock in BC. Okay. Now, I'm going to try to make this as efficient as possible. So watch what I'm going to keep turning that length until it comes up here. Are you kidding me? I actually hit it through A. I did not think that was going to happen. That is freakish. Okay, so if it didn't go through A, if A, okay, now I'm going to pretend I didn't do that. I'm just going to label A right here. And I'm going to erase that one because that I've been teaching for a while. I don't think I've ever done that. Okay, so A is right here. But as I turned C up, I created a new point, and I'll call that point D. Okay, there we go. Oh, I've already got D. Maybe I'll call that point oh, it's C. C just moved. So I'm going to create this point up here, C prime, because I rotated. Okay, there we go. Okay, there we go. I'm very excited if you can't tell, because I somehow managed to put points right on that were exactly the same length away. That just hasn't happened for me ever. Now watch this. Take that length, come down, put your pokey part at D, okay, and make a little bit of a turn. Okay, so what I just did is I replicated basically point C right here. Point C is kind of now located right there, or at least that length is located down here. Take that pokey part again, put it in, and I want to take that length and I'm going to turn an arc up. I'm not sure how high I want to go, but I'm just going to turn an arc because every point on that arc is now the same length. Okay. Now, the last piece I need is I need to make sure that I have exactly the same triangle. So I'm going to come right up here, put the pokey part at C, And then I'm going to adjust the side length until I get through C prime. And I'm going to make a little cross here just to make sure. Okay, it went right through that point. Okay, now watch. Take this length, bring it down here, and I want you to see what I've just created. What have I created? I've created a new point. Now it's based on the idea of a triangle. If I was to connect C with C prime, I want you to see this. No pun intended. This length right here is exactly the same as the length right down here. Those are exactly the same length by construction. Now the length from D to this new point, I don't know what to call it. I'll call it F, I guess. And up here, this point is kind of rotated. I don't know what else to call it. G, whatever. G. Okay, so what I know now is that C to C prime is the same as F to G. I know that B to C, that length, matches D to F because I locked that into my compass. And then I turned that length just like I turned up here. So the length from B to C prime is exactly the same as both of those. And so as I construct this right here and draw it back, what you can see is a really beautiful piece where the triangles have a side that matches, another side that matches, and then a third side that also matches. So the triangle C prime BC would be congruent to triangle, make sure they match up, GDF by side, 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 because all the sides were congruent. That means that angle C prime BC is congruent to angle GDF because corresponding parts of congruent triangles are congruent. So I've just created two congruent triangles, and in doing so, I have managed to copy perfectly the angle you had up here. And I want to bring up the fact that I didn't need to know how big the angle was. I don't need a protractor here. I know these angles are the same. I don't even have to measure them. I know because I've constructed them to be exactly the same. So that means if you are given an angle, you can copy an angle. If you're given a side, you can copy a side. If you are given three sides, which is an entire triangle, you could create a copy of that triangle by using the techniques that we just demonstrated. So I'm going to create here triangle A, B, C. I'll come down and say, let's move it over here. Let's create an exact carbon copy. And so I'm going to call this D. And so again, if I want to create a triangle so that triangle ABC is congruent to triangle DEF, then D has to match up with A, F with C. So I need to find form C over here, and I need to find point B, which will match up with E over here somewhere. So let's see how to do that because it's not really too bad. As a matter of fact, it's kind of quick. First things first, I'm going to go lock in the length from A to C. And again, I'll just twist. Oops, sorry, paper's moving. Twist my compass to lock in this length right here. I'll do a quick little twist to make sure it goes through. Perfect. And then come over here, pokey part in D, and do a quick little turn. Okay. Think about what I just built. I just built the point that matches C, and the point that matches C I would label as F. So there's a point. Now I can come up here and measure from A to B. And again, I'll use the wheel to modify a little bit. Make sure that it goes through. Perfect. Come down here to D. And this is where I think sometimes students get a little bit, they're like, what am I supposed to do? Just turn an arc. Just turn an arc. We don't quite know where it is exactly, and that's okay. Okay, so I've measured, and I know AB is this distance right here. And then I can go back and adjust, and I can lock in my third distance, which would be from B to C. And so just come over, lock that distance in, give a little twist to show it goes perfectly through, and then come back to the point we drew for F and create an arc. And now you'll see wherever those arcs meet up is where all of the different lengths that are BC match up with all the different lengths that are AB. And guess what? There's only one time where they match up perfectly. And so this would be point E. And then if you connect them, what you've done is created a new triangle that has exactly the same dimensions as the first triangle. So we would call that congruent triangles. And if you cut these out, they will sit right on top of each other because of how we built them. So that's how we can construct. If somebody gives you a triangle, you can construct a perfect copy of it. If they give you an angle, you can copy the angle. Effectively, we're basically copying the the sides and creating a congruent triangle. And up here, we can always move lengths like we just showed as well. Okay, so those are three of the big pieces that we saw in this section. I'm going to jump in here and do a new share and see. Doop, 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 doop. Let's see if I got all those pieces that we need and what other pieces do maybe I need to do here. Okay, congruent triangles. So we saw that. Side, side, side. So we built one of those. Constructing a triangle congruent. So I did that one, demonstrated that. Constructing congruent angles. We also copied an angle. Okay. And side angle side congruence. So again, if I know two side lengths and I know an angle already, then I can use that angle and then just make the different lengths with my compass, turning the different arcs, and boom, we're good to go. So we can actually go through and construct that. Okay. Let's see here. Yep, so that's building something with side angle side congruence. I guess I can demonstrate that as well. And then no constructions here. Perpendicular bisector forming altitudes. So that will be this one right here. So I will demonstrate that. So I'll show how to construct that, and then we'll do the circumscribed circle. Okay, so let me go back to, I got to share my other camera here. Okay, let's see, are we back? Okay, we're back. All right, so let me move to a fresh sheet of paper. Plus, these are super cool, right? Obviously. All right, so let's let's take a look. So I said one of the pieces I need is a perpendicular bisector. So what I'm going to do is I'm just going to create a segment using my straight edge. Okay, any segment you want. So I'm going to create A, B. And my goal is to create the midpoint, but I'm going to do that by creating something that's even more powerful than just finding the midpoint. I will be able to find a line that is perpendicular to this. And we're going to do that by finding some congruent triangles. So what I'm going to do is you can put the pokey part on one side. And honestly, for this one, you can adjust with any length as long as you keep it the same. So I could turn up and down with any length. I've ran out of paper. So I'm going to shrink this down a little bit. Okay. And then pokey part at A. Okay, there we go. Okay. And all I'm going to do, I want you to notice, all I'm going to do is just draw an arc. So again, it's easy to think compass straight up and down, tip it to the side, and you can make a really beautiful arc. So I'm going to do an arc here and keep the same arc kind of going down below. Everything on this would be the same distance to point A. Now, come over here to point B, and I'm going to turn the same. Notice I got the same length in my compass, same length. All right. So let's see what we just created. I've created point C up here and point D down here. Using my straight edge, I'm going to construct a couple of triangles. so that you can kind of see. So this side length here has to be exactly the same length as the side length down here at the bottom. Okay. And likewise, if I come over, I can make these 2 points. These two have exactly the same length because they're both the same distance from point B. And likewise up here, I can draw those two that go perfectly together as well. Okay. So let's label what we have. This length here is the same as that length. As a matter of fact, because I kept the same length for all of them, all 4 are the same. I actually just built a rhombus. Okay. And so then I have this piece down the middle that is also identical. Okay. So if you look to the side, what do I have? I have triangle A, C, D has to be congruent to triangle A. Why did I say ACD? ACB. Sorry about that. Doesn't erase quite as quick as the digital one. ACB, so this top triangle, is going to be congruent to ADB. That's the bottom triangle. And if you notice why, it's because I have sides that match, and then a side that matches. So this is by side, side, side. Okay. So that is awesome. Now, what does that mean to us? It means that angle CAB is congruent to angle DAB. So that's CAB, which would be this angle right here, is now congruent to angle DAB, which would be this angle right there. Those are the same angles because the corresponding parts of congruent triangles are congruent. Phew. But again, the whole point of this was to create something that splits AB. And we've done a whole bunch of cool stuff, but we haven't done that yet. So I'm going to take my straight edge now, and I'm going to create the line that goes from C to D, which is going to build us a new point right here in the middle. And I'm going to call that point M. Excuse me. Okay, so point M. Now let's take a look. This is where we got to be very, very careful. I want to say that AM is the same as MB, but I don't know it yet. So I have to be able to prove that. But I do know that CM, right, looks like that one could be halfway between. But again, I actually don't know that yet. Let's take a look at what we do know. Okay. I do know that, let's see, I have this angle's the same as that angle. This side's the same as that side. And, oh, I could say AM right here would be the same for both of these triangles. So I do get some triangles that are congruent. And this would be, so I now know that AM is congruent to AM, which seems a little strange because it's congruent to itself, because it's the same shape. And so now I have all these beautiful pieces but that I constructed. So I'll list those as well. I'll see AC is congruent to AD, and that was by construction. Okay. So I have AC, I have AD, I have the angles that we've already listed, and now I know AM is congruent to itself, and that gives me a side, an angle between, and then another side, which tells me now that triangle CAM is congruent to triangle DAM. Okay, so that's now this triangle here on top is congruent to the little triangle down here underneath. And that is by our side angle side property. So now I pick up all the other angles that are congruent for free. That means angle AMC is congruent to angle AMD. D, because corresponding parts of congruent triangles are congruent. So now I know this angle is the same as that angle, but I know something else. These are supplementary. And we know they're congruent. So both are 90 degrees. Okay, so that means up here, I actually can mark, instead of just marking an angle mark, I could put that this is actually a right angle. And I know the one next to it is a right angle. And because of vertical angles, I actually know all of these are right angles. Yeah. So that is still point M, but I get a right angle there. All right, look at that. That's pretty cool. So now I have to be kind of careful and say, well, wait a minute. If I know a few other fun facts about this, for example, I know triangle ACB is isosceles, which means that its angles opposite are identical. I could pick up that this angle here, CBA, is the same as CAB. And likewise, for the triangle underneath, I could pick this up. So angle CAB is congruent to angle CBA, and angle DAB is congruent to angle DBA, since the triangles are isosceles. And now, again, there's a lot of other pieces that I could figure out, but if I want to show that AM is the same as MB, I need two triangles that have to be congruent. And so now I'm going to take a look at, let's see here. I wonder if I've got another colored pen sitting here. I guess I've got this pen. So now what I'm going to do is I'm going to focus on the two triangles here at the top. So the triangle here to the left, I'll outline that one in black, so it's a little bit darker. And then the triangle right next to it here. So the triangle black and the one right next to it. I'm going to say, I think those two are congruent triangles. I think I have enough pieces. And if I can convince you of that, then we'll be able to say that the remaining sides have to be the same. And that means M is the midpoint. So in order to do this, I might also come up here and say, let's see here. The triangle I had right here, CAD, is isosceles, which means I get some angles that would be congruent. So I know this angle right here will be congruent with the angle down here. I know this triangle over here is also isosceles, and it's we already had some pieces that are congruent there. So side, side, and the middle side. So I'd pick up another beautiful piece. I could say, aha, these angles right here have to be exactly the same. And now I could say that, I guess I'll leave that for now. I could say that we know that AC is congruent to CB. And that was by construction. And I know that angle ACM is congruent to angle BCM. And that's by the CPCTC. So now I've got that angle here. And I also know that this length down the middle is the same for both. And CM is congruent to CM by same shape. And that's all I need. I have now side, an angle, and a side, which is a side, an angle between them, and another side. So triangle AMC is congruent to triangle BMC by side angle side. And then I'll put 3 little dots, which is like a fancy math way of saying, aha, here's my big conclusion. My big conclusion is that AM has to be congruent to MB, since corresponding parts of congruent triangles are congruent. So this shows that when you do this construction that we just did, that the length of the pieces on each side turns out to be exactly the same, which means M is the midpoint, and that the line that we create coming down creates 90-degree angles. So that's why CD is a perpendicular bisector of AB. And that is how we can create a perpendicular bisector. So create a shape, turn up, turn down, connect them, and off we go. And we'll be using that perpendicular bisector quite often. So how would we use a perpendicular bisector? Moving to another piece. Here's how. If you have a triangle, any triangle, you can create perpendicular bisectors. And what's great about the perpendicular bisectors is, okay, so there they are, that I can form them. One, I can form them very, very quickly. So I'm going to show how I form them here. Again, if I want to bisect this bottom length, I turn an angle up and I turn an angle down. And you can kind of see the faint arcs there. I don't need to make really dark arcs because I'm just going to change my pencil to the other side, swivel up and swivel down. So what I've created here is a perpendicular bisector if I connect those points. So this point right here, when I create this line, it's going to cut the first segment directly in half. So I've created a bisector, perpendicular bisector here. Okay. Next up, I could do the same thing for any of the other sides. I'm going to rotate my page and do the same thing for this top side, which means I can even keep the same length in there as long as it's more than halfway. So put my pokey part here, turn up, turn down, and repeat the process over here with this other point. Come on, pokey part. There we go. Turn up, turn down. Where those intersect creates a perpendicular bisector for the next line. And so as I do this, I've now created 2 perpendicular bisectors. I can do that for the third one as well. Just rotate my page a little bit just so we can see a little bit more clearly. And again, I can even keep the same compass length as long as it's more than halfway. Turn up, turn down, go to the other piece, turn up, turn down, find where they intersect. And when I draw this last one, sorry, let me get it right on here, going between these. Okay, what you'll see is all of the perpendicular bisectors intersect at a single point. And what's great about that point is if I put my compass point there and I swivel out to one of these vertices, assuming that I did everything correctly here, okay, then I can go through the point here, through the point over there, oh, and if I continue the circle, it will actually go through all 3 of the points on the triangle. So I have made a circumscribing circle, and this point that I created is called the circumcenter, the center of that circumscribing circle. So that is a cool feature that we can now do using our compass and straight edge. All right, So I think I've built everything that you need in 12.1, shown you how to do it here. And let's see here. Let me go back to share this screen. And just know that you can do the same things in some of the computer programs, and we're going to talk about those a little bit later in the course. But you can use technology to do similar things. Let's see here. GeoGebra. Oops, do not want that one. Do not want a probability, just want GeoGebra. They have a geometry tool with GeoGebra that allows us to build points, segments, and lines. So if I have segments like this, I can create the exact triangle, kind of like what I just showed. And one of their tools is that I can create arcs. So if I create a circle that goes all the way out over here, I can create another circle that goes all the way out over here. And notice that creates two new points where those intersect. And I can make a segment that goes between those 2 points. And I've just built a perpendicular bisector of BC. Now, what's great about this is I can actually go hide an object. So I'm going to hide those 2 circles because now as I look at it, it's going to be easier to just look at that perpendicular bisector. Okay, I'm going to repeat the same process with B and A. So basically, this is me turning with my compass, put the pokey part on the other side and turn again. Creates 2 points. We can see those points. And then I can create a segment between those 2 points. And once again, I'm going to hide the circles that I just created so that it's just a little bit easier to look at. Okay, 2 perpendicular bisectors. As you go forward, you'll realize you only ever need 2 of them because the third one's going to hit in the same point. But I do want to show you using this, what's known as GeoGebra, which is like geometry and algebra together, that you could create another one of these, and where these intersect, here and here, I could build a third segment, and that third segment hits at the same point as all of the others. Now I am going to go ahead and hide these circles just so that it's a little bit easier to see. And now I'm going to build a circle from that center point, and I stretch it out. And what you'll see is it goes through all of the points on your triangle. Now, the reason why this is kind of cool software-wise is I'm going to hide the line segments, which were the perpendicular bisectors. And I'll probably even hide the points, just so we can really just see what happens to that center shape that I built. E, F, and I. Okay. So take a look at that point. What's great about this software is I can grab a point and move it so I can create different triangles, but all of the constructions remain behind the scenes. So as I switch and make a very obtuse triangle, you can see where the center would have to be. But I could also stretch this up and say, oh, I could make an acute triangle. And now you can kind of see, oh, that's where the center would be, right? It would be right there. So this is known as dynamic geometry software. It allows us to do things that maybe we wouldn't be able to do with just a piece of paper and pencil because we'd only have one drawing. But the same things you can do on paper are the things that we can do here. And I think that's pretty cool. All right, that's it for now. So again, I'll try to do these because we're doing constructions. I'll do one video on the construction and one video on the kind of the chapter pieces or the concepts. So hopefully that ties everything together. All right, off you go.